asteroids flying past Earth, what we're seeing in the night sky is anything but normal. And now, astronomers have no choice but to start asking, what is 3I Atlas really doing to our solar system? Stay with me on this late-night exploration as we uncover whether we're witnessing the galaxy's greatest coincidence or something far more profound. Part 1. An asteroid wave is coming. Mid-September 2025 was supposed to be quiet. Just another month of routine cosmic traffic, the kind astronomers catalogue with mechanical precision before moving on to their next observation. But the universe had other plans. What unfolded in those crisp autumn weeks was something entirely different, a celestial parade that left scientists scrambling to their telescopes and the public wondering if we were witnessing something more than mere coincidence. The headliner arrived first, Asteroid 2025, FA22, a mountain-sized chunk of rock measuring somewhere between 130 and 290 meters across. On September 18th, it swept past Earth at just over 2 lunar distances, roughly 835,000 kilometers away. Close enough to make headlines, far enough to let us sleep soundly. But here's where the story gets interesting. FA22 didn't come alone. This wasn't your typical lone wolf asteroid making its scheduled appearance. Instead, it felt more like opening night at a cosmic theatre, with multiple performers taking the stage in rapid succession. Small near-Earth object 2025, RJ2, had already made its entrance 3 days earlier, on September 15th, buzzing past at just 0.78 lunar distances, a mere 300,000 kilometers from our doorstep. In astronomical terms, that's practically a handshake. But these weren't isolated incidents. Throughout that same week, dozens of additional sub-lunar distance visitors painted their trajectories across our local neighborhood, each one catalogued and tracked by the global network of space surveillance systems. It was typical traffic by the numbers, yet something about the clustering felt different. The timing seemed almost choreographed, as if these ancient wanderers had coordinated their arrival for maximum dramatic effect. Then came the supporting cast, Comet C/2025 R2, discovered by the Swan instrument aboard the SOHO spacecraft on September 11th, began brightening toward naked eye visibility near the constellation Virgo. Its tail stretched across the evening sky like a cosmic brushstroke, visible to anyone who knew where to look as twilight surrendered to darkness. The comet's fate beyond perihelion remained uncertain. Many such objects fragment under the sun's intense heating, leaving behind only glowing debris trails as monuments to their brief stellar careers. Meanwhile, lurking in the background of every astronomical news report was another familiar face, Apophis, officially designated 99,942 Apophis. This is the asteroid that once topped every planetary defense worry list, the 400-meter-wide mountain of rock, scheduled for an uncomfortably close encounter with Earth on April 13th, 2029. That flyby will bring Apophis within 32,000 kilometers of our planet's surface, closer than our geostationary satellites, close enough to see with the naked eye as it screams across the night sky at 50,000 kilometers per hour. But the real star of this celestial show was still waiting in the wings. Hidden among the routine discovery announcements was something unprecedented. 3I Atlas, also known as C/2025 N1, discovered on July 1st, 2025, by the Atlas survey team in Chile. This object was different from everything else, crowding our telescopes that September. It wasn't just another asteroid or comet from our local solar system family. This was something far more exotic, an interstellar visitor, only the third ever confirmed, carrying chemical signatures that would challenge everything we thought we knew about planetary formation. The Atlas team had initially spotted it as just another fuzzy dot moving against the star field, but as follow-up observations refined its trajectory, the mathematics told an extraordinary story. This object was traveling on a hyperbolic orbit, meaning it possessed more than enough velocity to escape our sun's gravitational embrace entirely. It had come from somewhere else, another star system, perhaps light years away, and after its brief encounter with our solar neighborhood, it would continue on into the cosmic dark, never to return. What made 3I Atlas even more remarkable was its timing. Perihelion was scheduled for late October 2025, just weeks after the September asteroid parade. Then, like a performer exiting stage left, it would vanish into the solar glare, hidden by our star's overwhelming brightness. But patience would be rewarded. In early December, as Earth's orbital motion carried us to a better viewing angle, 3I Atlas would re-emerge from behind the sun's curtain, offering telescopes their best opportunity to study an authentic piece of interstellar real estate. The observing window was perfect. Too perfect, some might say. At closest approach in December, the object would still be 1.8 astronomical units away, roughly 270 million kilometers from Earth. Far enough to pose zero threat, close enough for detailed spectroscopic analysis by our most powerful instruments. It was as if the universe had delivered a carefully packaged sample from another star system, directly to our astronomical doorstep, complete with optimal viewing conditions and a leisurely timeline for study. But why now? Why this sudden surge of cosmic activity clustering around the same few weeks? Better surveys certainly played a role. The Vera C. Rubin Observatory had just captured its first light images in June 2025, netting thousands of new asteroid detections in approximately 10 hours of operation. More eyes were scanning the sky with greater sensitivity than ever before, revealing the true population density of our solar system's small body constituency. Yet the timing felt too convenient, too orchestrated to dismiss as mere observational bias. Was there something special about September 2025? Some gravitational confluence or seasonal alignment that had drawn these objects into convergence? Or were we witnessing the first act of something larger, a cosmic drama playing out on timescales far beyond human perception? The mood among astronomers wasn't fear, but urgent curiosity. Planetary defense systems had evolved considerably since the days when impacts were purely the realm of disaster movies. We now possessed the technological capability to track, characterize, and even deflect potentially hazardous objects. The recent success of NASA's DART mission had proven that kinetic impactors could successfully alter an asteroid's trajectory, while the European Space Agency's Hera mission was en route to forensically examine the results. But knowledge and preparation were only as good as the warning time they provided. And that raised uncomfortable questions about the visitors we hadn't seen yet, the ones still approaching from the direction of the sun, hidden in the glare until their final approach. If FA-22 had been on a collision course instead of a safe flyby, would we have had enough advance notice to mount an effective response? And what did 3I Atlas, with its alien chemistry and interstellar origins, tell us about the unseen population of objects drifting between the stars? The September surge had awakened something in the collective scientific consciousness. It wasn't panic. It was the recognition that our solar system was far more active, far more connected to the broader galaxy than we had previously imagined. We were witnessing the opening act of humanity's transition from a single-planet species to active participants in galactic-scale phenomena. But first, we needed to understand